Now that we know a little bit more about functions, we can talk about circles, and some of this stuff should start to look a little bit familiar to you. We're going to see a lot of formulas that should look familiar to you today. The first of those formulas is the distance formula. This is a formula you should make note of, write it down in your notes, memorize it if possible. That is the distance formula, and it's specifically the distance between 2 points, between any 2 points. You can take any 2 points, sub in the x values and y values for those points, and find the distance between those 2 points. Here's the example that we're given. Find the distance between the points -5, 1 and 7, -3. Give the exact distance and the approximation to 2 decimal places. So that's going to be 2 separate blanks in your homework and 2 separate blanks on the test. If we label these points x1, y1, x2, y2, because we know every coordinate is a x, y coordinate, right? We could sub those values into the distance formula. x2 minus x1 would be 7 minus -5 squared, plus y2 minus y1 would be -3 minus 1 squared. I tell people always that if you can sub this entire piece into your calculator, the 7 minus -5 squared, that entire thing, sub that into your calculator and get a number, that will help you out. Sub it in exactly how it sits. 7 minus -5 squared, you get 144. -3 minus 1 squared, you get 16. When you add those two together, you get 160. And you're going to break that down with a factor tree just like we have been. 16 and 10, 2 and 5, that's the same as 4 and 4. 4 is 2 and 2. This 4 is also 2 and 2. Our prime factors here are 2, 2, 2, 2, 2, and 5. And we're always looking for buddies when we're taking the square root. So here we'll have a 2 and a 2 that get to go outside. They have buddies. So that's the same thing as 4. This 2 and this 5 don't have buddies, so multiply them to stay inside, square root of 10. That's our exact distance between those 2 points. It says give the exact distance. It also says give an approximation to 2 decimal places. So to give an approximation to 2 decimal places, I'm just going to type that in the calculator. 4 square root of 10, exactly how it sets. On the calculator, just to the left side of the 4, there's the x squared button. If you hit second and hit that button, it'll give you the square root symbol. And you want 4 square root of 10. In the calculator, you get 12.65. If we're rounding it to 2 decimal places, on my calculator I get 12.649, which rounds to 12.65. If we want to know if 3 points form the vertices of a right triangle, like this question's asking, determine if those 3 points form the vertices of a right triangle. What we know is for a right triangle, for every right triangle, this is true, that a squared plus b squared equals c squared. So if we can make that true, if the 2 smaller sides, square, square, add up to equal the larger side squared, then we'll have a right triangle. Let's see how long each of those sides are. To find the lengths of the sides, we could just do the distance between any 2 points. So the distance between M and P is the length of one of those sides. The distance between M and Q is another side. The distance between P and Q is the final side. And what we need to know is the smaller of those two, the 52 and the 61. If we take the square root of 52 squared plus the square root of 61 squared, does that equal the square root of 101 squared? The square and square root are inverse operations, so does 52 plus 61 equal 101? 52 plus 61 in the calculator gives me 113, and that does not equal 101. So that does not form a right triangle. Another important formula, what we're trying to get to circles here is what we're trying to build up to. So a circle, trying to build a circle, you need to know what the radius of the circle is, which would be the distance from the midpoint to any of the points on the outside. You need to know what the midpoint is. Well, the center of the circle, right? Which would be the midpoint between any 2 points on the circle. So the midpoint formula is given to you here as well. This is another formula that you should just commit to memory. It's the average of the x's, the average of the y's. Notice that it is a point, right? It's 2 coordinates. These 2 things don't get put together in the end. It's 2 separate things. So to find the midpoint in this example of the line segment with endpoints given, We can again call these x1, y1, x2, y2. So then the distance, we're not trying to find the distance, the midpoint would be 4.2 minus 2.8 over 2, negative 4 plus 3 over 2. In my calculator again, 4.2 minus 2.8, I'm going to do that part first, 2.8. I get 1.4 divided by 2, comma. Negative 4 plus 3 is negative 1. And 1.4 over 2, 1.4 over 2 gives you 0.7. So 0.7, negative 0.5. That's your midpoint. These two formulas are easy peasy. We're just taking x and y values and subbing them into the formula to get a final value. All right, writing an equation, now that we're into actually circles, we have a standard form of a circle. This right here is standard form of a circle. Just like with lines, where we still have the x and the y in the end, ax plus by equals c, the x and the y remain in the formula. Here the x and the y are going to remain in the formula, but everything else, the h, the k, the r, are all going to be numbers, okay? The numbers mean something in this formula. The h and k that you see in this formula are the points of the center. It's the x and y coordinates of the center. And the r is the radius. R is the radius. Notice that in the formula that's r squared, so oftentimes this number over here is going to be a perfect square. Not always, but oftentimes it will be something like 49, because we know that 49 is 7 squared. This is just an example. Let's see what we can do with this. Write the standard form of an equation with a center at negative 4, 6 and a radius 2. So if we sub that into the equation that we have, this would be hk. This is an important piece here, is that minus is already built into the equation. So when you're subbing in, if you have a negative number, you have to take that into account. That's the same thing as x minus negative 4. I'm just going to write that as x plus 4. Y minus, k is a positive 6, so just y minus 6. The negative is built into the formula there. You see it? And then on the right side is r squared, 2 squared, which we can again just write as 4. I lost my squared there. Okay, so some common mistakes here on this formula are exactly what I just did, leaving off that square. You have to have a square with both of the parentheses on a circle and not changing the sign. So if this is a negative 4, that's x plus 4. If that's a positive 6, that's y minus 6, right? The negative is built in. Also, not squaring the number that goes there is a pretty common mistake. This is our equation of our circle in standard form. It says to also graph the circle. Graphing a circle is easy. On Alex or Pearson, what you do is you start with the center. So this center, it tells us, is negative 4, 6, right? It has it right there. The center is at negative 4, 6. So I need to go back 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. Draw my dot there. We can keep this color coordinated. And then a radius of 2. A radius of 2, we can go in any of the cardinal directions. That means north, south, east, or west. We can go north, south, east, or west by 2, and it should autofill our circle. So if I go south, 1, 2, draw a dot. You could also go east by 2, you could go west by 2, you could go north by 2. You see those points are forming the circle. On Alex, when you pick any direction and go in that direction by 2, it should automatically form the circle for you. You can go north, south, east, or west by 2. This says write the standard form of an equation with endpoints of diameter, negative 1, 0, and 3, 4. So I went on and drew out a diagram here. The endpoints of a diameter of a circle goes all the way across the circle, right? If we know the diameter, what we need to know to write out the circle's formula is the center and the radius. To find the center of that, we need to find the midpoint. So the center, we need to find the midpoint, which would be x1 plus x2 over 2, y1 plus y2 over 2. So that's 3 plus negative 1 over 2, 4 plus 0 over 2. So that would be the same as 2 over 2, which is 1, 4 over 2, which is 2. There's our center. And now we need to know the radius. So the radius is the distance from the center. That's the point 1, 2, right? The distance from the center to the outside is the radius. So what's the distance between 1, 2, and let's just say 3, 4? I'm going to sub again into my distance formula. y2 minus y1, that's 4. Oh wait, it's x2 minus x1 squared. It doesn't really matter what order those come in, but I'm going to follow the formula here. So that'd be 3 minus 1 squared plus 4 minus 2 squared. So that would be 4. Again, I'm subbing this whole thing into the calculator. Subbing this whole thing into the calculator, you also get a 4 equals the square root of 8. That's the same thing if we wanted to simplify it as 2 square root of 2, right? We could break that down with a factor tree. I'm not going to bother with that right now. Let's just focus on this being the radius, right? That's the distance. Remember, we use the distance formula between the center and the outside to find the radius. So now if I want to sub in and find the actual formula of the circle, the standard form equation of the circle, I'm going to use my x minus h squared plus y minus k squared equals r squared. And the square root of 8 squared we can simplify. That's just 8. There is our standard form of our circle. Here's our h, there's our k, there's our r right there. Write an equation of a circle in standard form. All right, here is our something coming back to haunt us here. When we did completing the square back on quadratics, if you wanted to go back and review the equation that we had on quadratics, that would help you out at this point because we did complete the square. If we have a circle that is not in standard form, we have the entire equation of the circle not in standard form. To get it into standard form, we're going to have to complete the square twice. And you're going to follow these exact steps that I'm going to do right here. You're going to gather the x's together, so x squared plus 10x, leave some space. Gather the y's together, y squared minus 6y. I'm just gathering the y's, getting them close to each other. Leave some space. And then I'm going to move that 25. I'm going to subtract 25 from both sides so that it's on the opposite side. Then the next thing I'm going to do is I'm going to complete the square with each of these pieces. So with the x's, I would say 10. Half of that is 5. Square that is 25. That means I need to add 25 to both sides. Again, you can go back and review this on the quadratics lesson. With the y's, I have b is negative 6. Half of that is negative 3. Square that would be 9. So I need to add 9 to both sides. And now looking at my blue piece, if I do star method or if I remember that simple trick, I would have x plus 5 squared. Looking at my purple piece here, I could either do star method, or again, I could remember the trick and know that's y minus 3 squared. And then on the right side, all I have to do is add up those pieces. Negative 25 plus 9 is just 9. So there's my circle in standard form. And we need to identify the center. Center is coming from these. That's h, that's k. Radius, remember this is r squared. So if r squared equals 9, if you take the square root on both sides, the radius would be just 3. If r squared is 9, then r is 3. You could, of course, go and graph that the same way. You would start with the center, negative 5, 3, plot a point. You could go north, south, east, or west by 3, and Alex would automatically graph the rest of that for you. Example 4, determine if an equation is a circle. So we have, again, something that is not in standard form, right? It would be nice if we had it in standard form so that we could check and see if it fit that circle's form. X squared, already by itself, gathered. Y squared, I just moved things around here, right, to gather up the y squareds. With the y squareds, let me underline that in purple again. We have negative 14 over 2, which would be negative 7. Then when we square that, we would get 49. We need to add 49 to both sides. The x squared has nothing to add. There's no b term, so it's just x squared. That's the same thing you know as x minus 0 squared. We haven't had an example of that yet, but if we just have x squared, the center point there would be 0. The y's here, y minus 7 when you do star method or when you remember the trick, equals 0. All right, so then the center, if this was a circle, the center would be 0, 7, right? We're looking at that and that. There's nothing subtracted from the x. There's 0 subtracted from the x. There's 7 subtracted from the y. That's hk in the formula. And then the radius, here's where we have a problem. If that's r squared, then r, 0 squared is 0. The radius is 0. The question is, can you have a circle with radius 0? And this is the point where you realize that this is not a circle at all. It's just a point. There's no such thing as a circle with radius 0. I hope you've understood this. Again, if you need to go back and review something, what I would suggest going back and reviewing is simplifying radicals, right? That was important throughout this entire thing. And then go back and review quadratics where we talked about completing the square. That would help you out a lot here.